Hello viewers, welcome to my YouTube channel Infinity Learning. In today's video, you will learn how to solve an algebraic equation using bisection method using scientific calculator. Instead of our traditional method, we are about to use scientific calculator for all kind of calculations. So let's get into the video. Find the root of the equation x cube minus 4x equal to 9 using the bisection method corrected to 3 decimals. So I'm going to do this problem for 2 decimals for time consuming, and the convergence will occur very fastly, so that I'm consider 2 decimals for my calculation. Solution. So consider the given function by taking all the numbers, all the coefficients to the left hand side. So f of x equal to x cube minus 4x minus 9. So we are going to use calculator throughout the problem. So for iteration methods like bisection method, iteration method, regular falsing method, and Newton-Raphson method, we need to have an initial approximation to start the procedure. So for the initial approximation, we are about to use our traditional trial and error method. For that also, we are going to use our scientific calculator. So I will show how to use scientific calculator to find the initial approximation. We are about to use 2 decimal approximation, and therefore first we need to set up the uh, decimals, how to fix the decimals. So for that, press shift mode, and then in the sixth option we are having how to fix the decimals. So I'm pressing 6 and then 2 decimals, therefore we fix 2 decimals, right? So the 2 decimals is fixed. Now we have to enter the function that given in the problem. Okay, so the function is x cube. So I'm pressing alpha and then x, and then cube. For cube you can directly shift x square or x exponent to the 3, and then minus 4x, once again 4 into alpha times x, and then minus 9. So this is our function. So after entering the function, don't go for the equal to sign, directly go for the calc symbol. It will ask the value for x. You first given the value of x as 0 and then press equal to. It will give you minus 9. So it is negative. And then once again calc, press the value for x as 1. It will give you minus 12. Once again also negative. We are about to search for a sign change. Then press calc and then enter for the next value 2. So here also we are getting negative value. So then proceed for the fourth value. So x value is 3. For here we are getting a positive value. Okay. So the sign changes between 2 and 3. Now we can list the values we got from the calculation. F of 0 negative, f of 1 negative, f of 2 is negative, and f of 3 is positive. There is a sign change between 2 and 3. Hence there is a root lies between 2 and 3. So now we will go on to bisection method formula. So the formula is xn plus 1 is equal to a plus b by 2. So we need two values. So the sign changes between 2 and 3. So we will take a as 2 and b as 3. So in the consecutive approximations, a b values will be changed. The corresponding a and b values will be used in the formula, and then we will do the iterations. So since this is an iteration method, we need to stop the procedure only when the two successive iterations must be equal, corresponding to the number of decimals asked. Okay, so now we are about to use this formula using the calculator. We are going to type this formula in the calculator, and then we do one by one iterations. Okay, so let us see how to do using this in the calculator. So we are going to input the function that you have seen in the screen. Already we have fixed the decimal. So let us type the function x equal to means not this equal, this pink color equal to we need to use, right? So alpha equals to, and then a plus b divided by 2. So bracket a plus b, close the bracket, and then divided by 2. So what I'm going to do is I am going to find the value for x and then use this x to apply in the function f of x. So for that we can use this operation as colon and then type the f of x function. F of x is x cube minus 4x minus 9. So by giving this, we can do two calculations simultaneously. So if you do like this, then you can find the value for x also, and then using the colon option, that calculated x value will be used in the f of x also. So the two calculations will be done by using this only one expression, right? So now use our calc button to enter our value of a and b. Our a value is 2, and then press equal to our calc whatever, right? So 3, then our value will be 5 by 2. So you can find the decimal value for this button s to d. You can get the decimal value. Okay, so this is the value for x, and then press once again equal to symbol. You will get the value for f of x. Once again by mixing it minus 3.38. So our x value and f of x value is obtained. Now we will enter the value what we are getting using a calculator. X1 as 2.50 and the corresponding f of x1 value is negative. Now we will search for the immediate positive value for last positive value. Okay, so it is equal to 3. Okay, so for f of 3 we are getting positive value. So now we are going to use this a and b value in the calculation. Okay, so using this a and b value we will be getting x2 as 2.75 and immediately f of x2 is 2.80. This is a positive value. So now use first iteration negative and second iteration is positive. Therefore our new a value will be 2.50. Replace 2.75 as 2.50 and b value as 2.75. Therefore our new x3 will be 2.63 and f of x3 will be minus 1.41. I will show the calculation in the calculator also. Okay, so then immediate negative and positive occurs in the second and the third iteration. Therefore we need to replace a and b value. Therefore our new a value will be 2.63 and b value will be 2.75. We will be getting x4 as 2.69 and f of x4 as minus 0.29. Okay, so I will show how these values come, right? And then in the successive approximation we are getting these values. Okay, so up to 7th iteration I will show in the calculator, right? In the next iteration we will be getting our final value. Okay, we will go for the second iteration. So press calc, it will ask the value for a. I will be entering the new value as 2.5 for a and then press equal to. The b value will be 3. Okay, entering b is equal to 3, we will be getting 11 by 4, convert into decimal, it is 2.75. So this is our x2 and then press once again equal to. This is our value for f of x2. So in the PPT I mistakenly mentioned it as 2.80, it is 0.80 only. Okay, so this is positive. So next we will be move on to our next iteration. So calc. So we will be using our new a value as 2.50. Once again 2.50 is our new value. B value will be changed. Only one value will be changed in each iteration, right? So B value is 2.75. Why? Because in this situation only sign changes, right? So 2.75 we'll be getting our new x value. X3 is 2.63 and then corresponding f of value will be negative. It is minus 1.41, right? So our new x value once again it is 2.63, sign changed, right? So a value will be changed and then b value as it is fixed 2.75. Okay, so 2.75 as it is there. You no need to enter the value. Only one value will be entered for each iteration, either the a value or b value. It is already 2.75, therefore no need to enter, right? So press equal to, the new x value will be 2.69, right? And then press equal to the corresponding the corresponding f of x value will be 0. Minus 0.29, right? So proceeding like this we will be getting in the 7th iteration. I will skip on to the 7th iteration. Okay, so in the 7th iteration I am going to use the a value as press calculator and then 2.71. In the 7th iteration my a value will be 2.71. You do yourself, right? All the values will be come automatically. So 2.72 will be the b value. and then we will be getting our x7 as 2.72 and the corresponding f of x value will be 0.15. Okay, so this is our seventh value. Now move on to the eighth value. So this is 2.71 and this one 2. So we can easily observe that between 2.71 and 2.72 there won't be any other value. So in next iteration we will be getting the same value. So 2.71 and then 2.72, then the answer will be once again 2.72. So in the seventh and the eighth iteration we are getting same values 2.72. So this is where we need to stop our iteration. If the two consecutive iterations are same, then we need to stop our iteration. So we will stop our iteration here. Hence our seventh and eighth iteration will be 2.72. So these two successive iterations are same up to 2 decimals. We are about to finding 3 decimals, but I am only finding 2 decimals. It will take too much time. That is what I am reducing 1 decimal. Okay, so hence our solution must be 2.72. So this is only one solution. Since the given equations of degree 3, therefore we can have two other solutions. Those two solutions may be complex pairs or any two real solutions. So we are about to find only one real solution using this method. Okay. Thank you for watching this video. If you have any queries, you can comment below.